Hello and welcome back. Due to some suggestions, I decided to do today some integrals that do not involve further maths techniques, so they're accessible to people that do straight maths. However, they're not the most straightforward integrals to do. At first glance, they don't look very nice. So I call them double trouble because they share kind of like DNA. They have the same ideas behind them. So let's see how we are going to approach each of these integrals. Okay, let's look at the first one first of all. In fact, I made a mistake in there. Shouldn't be x to the 7 minus x to the 6. It should be just x to the 7 minus x and nothing else in there. Okay. The first thing that comes to my mind, I'll look at this particular denominator and I'll just think, first of all, this reminds me kind of things that you can do with partial fractions. Maybe factorize an x, so something like this. But then that doesn't look very nice, does it? I mean, x to the 6 minus 1, can we break it further? The answer is yes, we can. We can do the difference of cubes, but again, we're going to very advanced kind of like ideas. I don't know if you can see some of the more advanced people that are familiar with more identities. You can see that this can be split to x squared minus 1, and then is next to the 4 plus an x squared plus 1. I think I'm writing it correctly, but I could be a tiny little error in there. I don't particularly want to do this particular split. I mean, this is definitely can factorize further to x plus 1, x minus 1. Now, this on the denominator is not pleasant at all. This reminds me of cross twins and other things that I have done in the past. So I'm abandoning the idea of attempting to factorize the denominator at least for now. So what else can I do in there? What other options are available to me? Okay, definitely there's no sort of like the standard techniques like integration by parts, for example, bottom differentiates to top. So I can try a few substitutions, such as perhaps I don't know, u is equal to the whole denominator. I mean, of course, u is equal to x, quite silly. We shouldn't really be doing silly things. And then I'm start experimenting by manipulating this particular denominator. And after you try a few things, you might realize that in fact you can factorize something out of this particular denominator, but that something is not the x, is in fact the x to the 7, which sounds a little bit bizarre to start with. Let's see what happens if I factorize on the denominator, of course, and x to the 7. Of course, I'll get 1 here. And now, in order to make it work, I need an x to the power of minus 6. Let's just check rules of indices, of course. Yes, it is, of course, correct. Now, why do I want to do something like that? Now, if you look carefully at this particular bracket as it is, let's investigate and we say, okay, what does that quantity differentiate to? If we look at the differential of 1 minus x to the power of minus 6, this differentiates to, the 1 of course will disappear, the minus 6 will come to the front, it'll become a plus 6, okay, and the bracket now will gotta go x to the power of minus 7, which of course is the same as 6 over x to the 7, which of course it has the structure, it's something over x to the 7 that we got in there. In fact, people now that are very advanced can actually see and they can actually write the answer to this particular integral. If you cannot see it, okay, you may use a substitution at this stage. If you spot this kind of thing, sub u is equal to 1 minus x to the power of minus 6. What will happen in there? Let's find out du. So I'll do it by substitution for everybody to see. Although it can be done, I mean, I can certainly write my answer now once I've seen this particular line, and many others, I'm sure. So du is, sorry, du by dx, so we are straight math, so we'll write it properly. Du by dx, of course, as we just said, positive 6, x to the power of minus 7. Make dx your subject, so this will go du divided by 6x to the power of minus 7, which we can write further. It's probably easier if we write it as 1/6, careful, and of course this we can write on the top as x to the 7. We cannot move, of course, the 6, that'd be absolutely appalling. And my du, of course, which was there. Okay, if we put it in now, we'll get, let's leave the x to the 7 at the bottom. All of this bracket now has been called u, and my dx, let's make some space, is in fact 1/6 x to the 7 du with a 1, of course, on the front. The x to the 7 will cancel, that's why we've got this, and this is 1/6. 1 over u, of course, will integrate to the log of mod u. And if we want to finish this particular line, is of course put our substitution back in, which of course, let me just move out of the way so you can see both. U is 1 minus x to 6, so that will be of course 1/6 the log of 1 minus, I'm going to move out of the way in a second, guys, plus c, which you can write in, I mean, that's good enough now, it's been done. You can write it, I guess, as 1/6 log 1 minus 1 over x to the 6, and for those who want it even better, they don't like it like this, you can write it, personally I will write it with lots of 6's in there, x to the 6 minus 1 over x to the 6, 6 plus c, and this integral has been done. Is it difficult? Yes, I think it is difficult to actually see the very first step, but the techniques involved, once you realize that from this line to this line, are fairly elementary and fairly straightforward. Okay, let's go to the second integral now. As I said in the very beginning, these two integrals share DNA. Is that when I made them, they kind of like I was playing with exactly the same idea, so I've done two variants. I don't know if I've probably done a third one as well. Let's think about what technique is involved in here. At first glance, again, I might be thinking way too complicated, and I forgot to write something in there. The x in this particular integral, to keep everybody happy, is a positive number. Okay. So that might be giving a clue to the more advanced people. Why do I want x to be positive? Is probably because I'm going to factorize something out of the square root, and I want to avoid mods, basically. So the first thing that comes to mind is, okay, maybe some kind of substitution. As it is in there, the substitutions will not work, the standard substitutions, of course. You can try u is equal to x to the 5. We're going to hit the brick wall. U is equal x to the 8, brick wall. U is the whole thing here, brick wall. And the same thing if we try the whole of the square root. So after that, we have to think of manipulating this particular expression. And having done the first one now, perhaps we can think a little bit better as to what is needed. We're going to factorize something out of the square root, but because there might be mathematicians here that haven't seen pulling things out of square roots, it's probably better if I actually put extra lines for this one. So this is now, I'm going up there. I'm going to factorize, first of all, inside the square root, not the x to the 5, which is obvious, like in the previous example. You can try that, and again, it won't quite work. I'm going to try to pull out the x to the 8, the higher power, still inside the square root, and I'm going to get, of course, 1 minus x to the power of minus 3. Still in the square root. Again, at first glance, you might say, okay, does that differentiate to that? Perhaps the answer is no, because x to the power of minus 3 will differentiate some constant at the front, and then it'll be x to the power of minus 4, or 1 over x to the 4. I don't have a 1 over x to the 4 in here, or have I? Because don't forget that x to the 8 is at the moment inside the square root. I forgot the dx there, so I'm very bad. So let's first of all extend this just in case it starts raining and the square root gets wet. Let's put that in the middle because it's bad karma, and let's put the dx because we're getting a little bit sloppy with the handwriting. My handwriting can be appalling at times. So this is equal to, now using the rules of thirds, I'm going to do it here. I'm not going to just write it again. I'm going to split this square root in, actually let me just write, doesn't really matter. It's just actually quite quick, this integral. So rules of thirds, so that's the square root of x to the 8 times the square root of 1 minus x to the power of minus 3 in another square root, 1 and dx. And that's why I said x is a positive number, so we can avoid complicated things. I mean, most people are straight maths, they're not even aware what is the problem with just taking this square root, so they would have written down anyway x to the 4 for this particular one. Okay, so this is what we are, what we're having at the moment, and is again similar to what we've done in the last example. If you look carefully at the argument of the square root, the 1 minus x to the minus 3, if you differentiate, that will differentiate to nothing. The minus 3 times the minus give you plus 3, x to the power of minus 4, which of course is 3 over x to the 4. So I'm writing very informally, like the little jottings on the side as I'm thinking loud. So the something over x to the 4 is just there. So that means a substitution, u is equal to that, will produce a differential which looks like that, which will allow me to simplify my integral. So from this line to this line, let's use a different color pen. I'm going to put the substitution in red here. U is 1 minus x to the power of minus 3. Immediately we differentiate. du by dx is equal to positive 3 x to the power of negative 4, which of course is exactly the same. It's easier if we write it the more standard way, and then get a rearrangement for our dx, as dx is equal to let's write the du at the end first, times the x to the 4 to the top, and divide by the 3. So we're gonna put now these items into the integral, and what we're going to get. So after the substitution, let's leave the x to the 4 on the denominator. This, we called it now the square root of all of this. We called it we called u just the bit inside. We didn't call the whole of the square root. So we're going to write it, of course, as u to the power of a half, still at the bottom. And our dx, I'm going to write it here, is x to the 4 over 3 du, 1 still on the top. The reason we've done this substitution is because we know this will simplify in this particular fashion. Let's write it in index notation. So that's going to be a third. Let's not forget the third. The u at the bottom, sorry, the u to the half at the bottom, we can write it as u to the power of minus a half on the top. du, year 12 integration. Now increase the power by 1. So it's going to be u to the power of positive a half. And a third divided by half, is it 2/3? I can't quite see it, or is it 3 over 2? Let me just check it very quickly. What is it? A third divided by half is going to be 2/3. Okay, plus a constant. Okay, so all is left now is to put our last the substitution back in, our last line, 2/3, and of course u to the half is that inside the square root. So we can write it, I'll write it to the half, 1 minus, you can leave it like that, or you can write it like this, to the power of a half plus c, which again, if you prefer to have this bracket slightly different, you can write it to the half, or actually it might not be visible in the video, so I will write it here. So 2/3, and you can write this either as a square root, or you can also put this onto a single fraction. So this will look like an x cubed minus 1 over x cubed to the power of a half plus c. And this was the second integral done. Were they hardest to, what do you think? Well, I think they were quite hard, but they're definitely accessible by somebody just doing straight maths rather than further maths. They don't require specialist knowledge, although the initial manipulation in both cases was quite hard to see. I thought he was. Okay, I hope you enjoy them. Join them again very, very soon. And who's laughing now?